Building on Soroban just got a whole lot easier, thanks to Stella's integration with OpenZeppelin Contract Wizard. If you go to wizard.openzeppelin.com, we can simply click on Stella at the top, and this will give us a default contract. We can change the name of the token, the ticker symbol, set a pre-mint. This is going to be the amount of tokens that are minted when the contract is deployed and then sent to the deployer address. Let's set this to 1 million. You'll notice that in the code here, it's actually got the 18 decimals included in that figure. We're setting the 18 decimals here, token name and the token ticker symbol. We also have additional features. We can make it mintable if the deployer address wants to be able to mint these tokens at a later date. Burnable if you want people to be able to burn their tokens and reduce their token balance. And also pausable if you want the deployer address to be able to pause the contract. You can also set the license information at the bottom here, which we're using the MIT open source license. This is all built around the OpenZeppelin fungible token contract library, which has just been released on their GitHub repository. Note this has had an internal security audit, but they're probably still waiting on external audits before they publish it to a Rust crate. For this reason, we need to import it locally. To do this, I'm using a template library from my own GitHub repository. There's a full tutorial on this, which I'll link to in the description. So to import this library locally, I'm going to fork this repository. I'm going to go to code, then copy this git link. So if we open up GitHub Desktop, you can also do it via the command line, go to File, Clone Repository, add a URL, paste in that link, set the path to where you want it. This is fine for me, and click Clone. That will sync them files, and if we go into that directory, we can now see all them files here. Now I'm going to be compiling and deploying this using Windows Subsystem for Linux. Let's move into that directory and then run cargo build. While that's building, I'm going to take a look at the contract address. This is a standard default contract, and I'm going to copy and paste the one from the OpenZeppelin wizard. You can see we've got a seller dev token, STT, and all the variables we set. And then in that same tutorial that's linked to the description, we've got these console commands, which we're going to copy and paste in. If you haven't got the Stella client installed already, we'll need to run this one. And I'm going to go ahead and generate a new address. So let's run Stella keys. That will give us a list of commands. We're going to go Stella keys, generate. We need to give it a name, so I'll give this wallet the alias Stella dev. I've got an error here that the network's required. Let's try running Stella keys, address, Stella dev, and see what that comes up with. We've got an address here. Now I could fund this using the fund flag in the Stella client, or I can actually go to the Stella labs, which is just lab.stella.org. And there's an option here, an account and then fund account. Paste any address you want in, click get lumens, and it'll give you some testnet tokens. Now we've got some tokens on our account, we can use that to pay the transaction fee to deploy the contract. So let's go ahead and copy this command, which is going to build the contract and output it to WebAssembly. So let's go ahead and deploy it now. We're going to copy this command. It's going to need some alterations. Let's copy that, paste it into the terminal. And if you have a look at the constructor argument for this particular contract, it requires the environmental variable and just one field, which is recipient. And that's the address that's going to be minted the tokens when this is deployed. So let's go back, delete all this. And then I need the address of the deployer, which I want to receive the tokens. Let's copy that in from Stella Labs, paste that in. The only other thing I want to change is the source, which is the person that's going to pay for the transaction fees. I'm going to change that to Stella Dev. Let's go ahead and give this a go. Boom, contract deployed. Now, if we want to test this, we can try doing a transfer. Let's copy this command and make some changes. I'm going to do it in a text editor just to make it a little bit easier. And I want to do a transfer rather than the mint. So I'm going to change this to transfer. Let's have a look at the transfer command just to make sure we're going from to an amount. So the from address is going to be the address that has all the tokens, this one. To account could be anything. And then the amount Doesn't really matter as long as it's less than 1 million. Just remember you've got the decimals on there as well, so you'd have to add 18 decimals. This should be stellar dev. Pay the transaction fees, and we need to change the contract address here to the one we just deployed. So let's copy that. Here, this is our token contract address. Let's try send in some tokens. That's how you can build and deploy a Soroban token in minutes using the OpenZeppelin contract wizard. This isn't just about them tokens though. Over the next 6 months, we'll see more modules and libraries added, which is going to provide a base layer or a foundation layer for Soroban developers to build their business logic on top of. I hope you enjoyed this tutorial. If you want to learn more about blockchain development and building Rust-based smart contracts, then subscribe to the channel and check out the links in the description, which have a whole host of information for Soroban developers. Thanks for watching.